we're going to learn how to convert a recurring decimal into a fraction. First though, we need to understand what we mean by a recurring decimal. You're probably aware that 1/2 equals 0.5. 1/4 is 0.25, 1/10 is 0.1, and you might even know something like 3/8, which is 0.375. We say that these decimals all terminate. That's because they all stop. There are some fractions, however, where the decimal representation doesn't terminate. You're probably aware of 1/3, which is 0.33333, and that 3 goes on forever. 1/6 gives you 0.166666, and that 6 goes on forever. You've even got fractions like this, 123/999, which is 0.123123, and that whole section of 123 repeats forever. And you've even got 1/7, where there's a very large section of repeated numbers. We would say that these decimals all recur because they have a repeating pattern to them that never ends. Fortunately, there's a slightly easier way of writing each of these. Take the first one, 0.3 recurring. It's only the number 3 that repeats forever, so rather than writing it out lots of times, we just write the 3 once, but put a dot above the 3 to represent the fact that it repeats. In the next one, it's only the 6 that repeats, so we write it out again but with 1 6, but put a dot above the 6. In this next one, it's actually the 1, 2 and 3, they all repeat forever, so we put a dot above each of them. It is however accepted that we don't need to write the dot above the 2, we tend to just write the dot above the first and last number of the repeating sequence, so just above the 1 and the 3. So in this next one, loads of numbers repeat. It's the 1, 4, 2, 8, 5 and 7, so we could put a dot above each of them, but again, we only really need the dot above the 1 and the 7 because of the first and last numbers of the repeating part. Now we're ready to try a question. We're asked to write 0.2 recurring as a fraction and give our answer in simplest form. To start a question like this, write x equals 0.2 recurring, the number from the question. I then write this decimal in its full form, so 0.2222222 and so on. Notice I've put quite large spaces between each of the numbers. This will help me line up my numbers later on. Now what we do is multiply this by 10. So if we multiply x by 10, we get 10x. And if we multiply the decimal by 10, all of the digits move one space to the left. So start with the number that was x and move them all one to the left. So 2.222 and so on. And of course, because the number never ends, we introduce a new 2 at the end. What we can do now is subtract these. So starting with 10x take away x, which gives 9x, and then we write the equal sign. Moving to the right, we've then got 2 take away 0, which is 2. Then we have a decimal point. Then we have 2 take away 2, which is 0. Then 2 take away 2, 0. 2 take away 2, 0, and this will carry on. All of the 2's take away all of the 2's, just gives zeros. So what we end up with is 9x equals 2. Now 9x equals 2 is an equation we can solve. If you divide both sides by 9, on the left, 9x divide 9 is x, and on the right, 2 divided by 9 is just 2 over 9. So we found that x equals 2 over 9. But x was also equal to 0.2 recurring, the very first thing we wrote down in the question. So actually 0.2 recurring is just equal to 2 over 9. So we've changed the recurring decimal into a fraction. If you want to check that this is the case, get your calculator and type 2 over 9, or 2 divided by 9, and you'll see it really is equal to 0.2 recurring. Now we'll try another question. This time it's 0.37 recurring, with both the 3 and the 7 recurring. So we'll start like we did before, x equals 0.37 recurring. Then we'll multiply this by 10, which gives 10x, and of course all of the digits move one space to the left, so now it's 3.737373, and so on. The reason this worked last time was because all of the digits after the decimal point lined up nicely, so when we subtracted them, they all came out as 0. This isn't the case anymore. If you look at the 7 and the 3 here, when we subtract these, we'd get 4 and not 0. So this wouldn't remove the repeating part. So what we do is we carry on and we multiply by 10 again. So this time we have 100x. And if we multiply the last number by 10, it would now be 37.373737. Now there is a way of matching these up. If you look at the 100x and the x, every number after the decimal point now lines up. It goes 373737. So we can subtract these two. So what we'll do is we'll remove the 10x part and put that into the background because it's not going to be useful anymore, and do 100x take away x. To the left of the equals sign we have 100x take away x, which gives 99x. We can then write down the equals sign, and moving to the right we have 37 take away 0, which is 37. Every number after the decimal point lines up with the one below it. So 3 take away 3, 7 take away 7, and so on will all give zeros. What this leaves us with then is 99x equals 37. We can solve this equation like we did the other one, divide both sides by 99. So 99x divided 99 is just x, and 37 divided 99 is 37 over 99. We should always check at the end of the question if we can simplify, but this one can't simplify, so it's the final answer. For this next question, we've got a longer recurring decimal, 0.426 recurring. We'll start in the same way, write x equals 0.426, 426, and so on. We'll then multiply to get 10x, which is 4.264, 264, and so on. Unfortunately, the digits after the decimal point don't line up. So we'll try again. 100x now, 42.642, 642, and again, currently nothing lines up. So we'll try again. 1000x is 426.426, 426, and so on. Now if you compare the digits after the point for 1000x and x, you'll notice there's a perfect match. So we'll go ahead and subtract these two. What we can do then is set 100x and 10x into the background because we don't need those, and subtract. On the left we have 1000x take away x, which is 999x. We then have the equals sign. Moving to the right, 426 take away 0 is 426. And of course, we know all of the digits after the decimal point line up, so they'll all give zeros. What we're left with then for this one is 999x equals 426. And now we finish by dividing by 999 on both sides to get x equals 426 divide 999. Now this time this one does simplify. Both the top and bottom have factors of 3. So if we divide by 3, we get 142 over 333. You may have noticed some patterns in the questions we've had so far. For example, the longer the recurring part of the decimal, the more times we need to times by 10. You may have also noticed that the denominators tended to involve 9s, like 9, 99 or 999. This next question will make things a little bit different. Here we've got 0.15 recurring, and crucially, it's only the 5 that recurs, not the 1. So write that out, x equals 0.15 recurring. We then multiply by 10, so 10x equals 1.5 recurring. Now at this point it looks as though we're ready to subtract because all of the 5s line up, but what we want is that every single digit after the decimal point lines up. But the very first one doesn't. We have a 5 and a 1, so we will continue multiplying by 10. If we multiply by 10 again, we get 100x equals 15.5 recurring. Now notice that in the top two of these, all of the 5s do line up. That's every number after the decimal point, so we're ready to subtract. So we'll put the x1 into the background and do 100x take away 10x. 100x take away 10x is 90x. We can then write the equal sign. Moving to the right, 15 take away 1 is 14. And then again, all of the numbers after the point give us zeros. So what we have is 90x equals 14. So this time, rather than dividing by 99, we're just dividing by 90. So x equals 14 over 90. And again, this one can simplify. If you half both of those numbers, you'll just get 7 over 45, which is the correct answer to the question. So what was important in this question is making sure that every single digit after the decimal point lines up. If even one of them doesn't, you should carry on searching until it does. We'll now try one final question that's quite difficult. 0.6425 recurring, with just the 2 and the 5 repeating. So, start with x equals 0.642525 and so on. Multiply by 10 and we'll get 10x equals 6.425252 and so on. At the moment nothing lines up, so we'll carry on. 100x equals this. Now at this point some numbers do line up. You'll notice these 2s and 5s line up, but unfortunately the numbers before those don't. Remember, we want every number after the decimal point to line up, and the 2, 5 and 6, 4 in red here don't match. So we'll carry on. 1000x now, and again it looks as though 1000x might line up with 10x, but it doesn't quite, just because these two digits don't match. So we'll carry on again, and this time 10,000x, and finally we have some numbers where there's a perfect match. So 10,000x and 100x match up after the decimal point. So those are the ones we'll go for. We'll put everything else into the background and do 10,000x take away 100x. On the left, we get 9,900x, then an equal sign. Now you have to be careful with this next bit. We've got 6425 take away 64. If you need to, I'd advise just writing this somewhere separately and making sure you subtract correctly. This would give 6,361. And then of course, all of the numbers after the decimal point will just give us zeros. So we get 9900x equals 6361. We're going to need to divide by 9900 to get x equals 6361 over 9900. Unfortunately, this one doesn't simplify.